We finally get to Chapter 1, Section 3. This, for me, is a fun section. It's called Formulas and Applications. They are application problems. AKA, you know them as word problems, and I know a lot of students do not like word problems. They take a little bit of time. You have to read the problem, maybe read it again, maybe reread it a third time, to try to figure out what information do you need from the problem, how do I organize the information. I will tell you, though, that if you get good at solving these application problems, it is worth its weight in gold. It's all about organizing and keeping your thoughts together. So the first part of this isn't too bad. A formula is an equation. You know, like the formula for area of a circle, pi r squared. That's a formula. It's an equation that uses letters to express a relationship between two or more variables. Okay, you see them in physics class, you see them in chemistry class. Physics, they'll talk about velocity, they'll talk about the position formula, the position equation, which we will talk about in this course. That's more often than not used in the physics class. You're going to use substitution and equation solving to find information using a formula. That's pretty much it. You have to figure out what are you given in the original problem and where can you substitute into the given formula. So our first example, example 1, the formula, and here it is. I like to put a box around the formula so that I'm not missing any parts. The formula W equals 0.3x plus 46.6 models the average number of hours per week, W. So this is hours per week. Okay, that's what W means. Models the average number of hours per week, W, that Americans worked X years after 1980. So X is the years after 1980. When will we average 55 hours of work per week? So the question is when. So what are we looking for? Are we looking for W or are we looking for X? Well, X is the years, and we want to know what year. So we need to solve for X. Okay, and once we find X, we're going to have to do something with that because it's certainly not going to be a 19-something. All right, so let's set up the formula. W equals 0.3x plus 46.6. And now what do I know from the problem? Well, when will we average 55 hours of work per week? Well, that's my W, so I'm going to substitute 55 in for W. And I'm going to copy the other side of the equation. And notice now I have an equation with one unknown. I can solve for X. If you subtract 46.6 to the other side of the equation, you will get 8.4 equals 0.3x. And when you divide, you're going to see that X equals 28. But remember, in the problem, X represents years after 1980. So this is X equals 28 years after 1980. You have to actually figure it out. So it's 1980, add 28, and come up with 2008. So that is the year. That's when we will average 55 hours of work per week. Now, these are application problems, aka word problems, so you need to answer in words. If you do not give me a full and complete sentence in all your homeworks and on your tests and quizzes, then I take a point off for each one. So make sure that you're writing sentences. Those of you that are online in the e-learning, please take note to this. Some of you in the last homework assignment with the graphing, you didn't use graph paper or you didn't write the tables. I'm pretty specific in my videos. Excuse me. So make sure you're listening to the video. You must have a sentence. We will average 55 hours of work per week in 2008. Or some sentence as such that makes sense with what you're being asked. Okay, so not too terribly difficult. You take the formula, you identify what means what, and then you find what they give you and you substitute. Sometimes you have to convert an English statement to a math statement. So you have to do a little bit of translation. You've got to know what it means to increase. Less than. Less than is different than is less than. Is less than is an inequality. But if this is 13 less than a number, that indicates subtraction. Increase, of course, indicates addition. 14 less than, so I'm going to subtract. The product means multiplication of 6 and a number. Twice, what does it mean twice? That means 2 times, so multiply by 2. The sum, what's sum? Sum is addition. And the sum of a number and 29 is 54. Typically, we're going to see an equal sign where you see the word is. And then here, notice it says find the number. So it's not enough just to write the equation. We're going to have to actually then solve the equation. And then finally down here at the bottom, 5 more than, well, that's addition. 4 times a number, well, that's 4 times some number, is equals that number, whatever we used here, x, y, whatever the case may be. You're going to use the same variable here, increased by 35. Well, that's addition. So we have to build the equation and then find the number. All right. You could, if you wanted to, in pencil, try to do these on your own by pausing the video and then resume the video to see if you got what I got. That's probably the best thing, especially with this hybrid learning. Like, try it yourself and then learn from any mistake that you might have made. There's nothing wrong with making mistakes as long as you know why it's a mistake. Okay. So, hopefully you paused, and now I'm resuming. A number increased by 13. A number, I don't know what the number is, so I'm going to call it x. So here's my number, and increasing it by 13 means to add 13 to it. 13 less than a number. 13 less than a number. Folks, the number has to come first, because you're taking a number and decreasing it by 13. So this is my x minus 13. If you had 13 minus x, no, that would be a number less than 13. Okay, so that's not what this says. This says 13 less than a number. The number comes first and you decrease it by 13. 14 less than something. So I know I'm going to subtract 14 from something. Okay, 14 less than, okay, less than what? The product, this is multiplication, of 6 and a number. Well, here's the product of 6 and a number. I like to use x for my number. Twice the sum. Twice. This means multiply by 2. And what am I multiplying by 2? I'm multiplying by 2 the sum of a number and 20. So here's my twice. And this is a binomial, the sum of a number and 20, x plus 20. Okay, so be careful with those. You do have grouping going on there. Okay, so I want the sum of a number and 20 2 times. Here's my sum of a number and 20, and then I multiply by 2, and that's going to get it to me 2 times. Almost done. The sum of a number and 29 is, this is like my breaking point for my equation, okay? The sum of a number, so it's the left side I got to put together. The sum of a number and 29, well, that's x plus 29 is or equals 54. That's my equation. And now I'm going to solve the equation by taking 29 over, and I find that x equals 25. I'm going to say that the solution is 25 in set notation. Remember, when you're solving equations, you must use set notation. Okay, so this is the first answer, and this is my second answer. All right, one more, and then that's going to be it for this video. We're going to do some more application problems where we have to read and identify things and substitute, build equations. That'll be in the next video lesson. 5 more than 4 times a number is. I like to stop at is, and that way I know this stuff goes on the left side of my equal sign. Okay, now I'm going to read the left side again. Excuse me, I'll take care of this side later. 5 more than. That means add 5. 4 times a number. All right, well, I've got 4 times a number and then add 5 to it. Okay, 5 more than, 5 more than, 4 times a number, 4 times a number, is that number, I used x for the number, increased by 35. So I take that number x and increase it by 35. This is my first answer. That's the equation. And now I'm going to solve it. Take the x over, you get 3x. Take the 5 over, you get 30. And now you see that x equals 10. And so my solution to this equation is 10. And I put it in set notation. So it's just reading, comprehending, knowing what's going on, knowing your mathematical terms, product, sum, difference, less than, increased by, multiply by, 2 times, all of that good stuff. So if you have any questions, post a comment on the discussion or ask a question in class. What else could you do? I don't know. You could talk to each other about it. You could look some things up online, YouTube videos, anything that's going to get you the help that you need. Or stop in the Google Meet. I do Google Meet every morning. Hardly anyone comes, except they have to come my e-learning on a Monday. Okay, I hope you enjoy this section as much as I do. Have a great day.